Great, welcome to my next video. This video will talk about the spanning tree protocol. Now, what was the need to have this protocol? Where did it start? There were two problems that were addressed by this protocol. The first problem was the L2 layer loops. Now, switch 1 and switch 2. And they are connected by two wires for the redundancy purposes if you have two wires. If spanning tree protocol wouldn't have been there, then the traffic, once it starts from here, reaches, will also be sent back to the same switch. This is kind of a, you can say, a loop that can get created in two switches. Right now, the second problem that we have had was the duplicate Unicast frames received at the destination. So consider the situation. Let's say you have a switch 1 and there's a PC connected, and then you have switch 2 and switch 3 and PC 2. Let's say the frame from this PC1 was destined for PC2. What will happen? This switch will broadcast the traffic here and here. Finally, this switch will broadcast the traffic here. So at this point, both the traffic, basically from here and from here, will actually reach at this PC2. Duplicate Unicast frames. So to address these two problems, STP came into picture. Let's see how STP solved these two problems. Let's consider a certain topology to understand this. Let's say we have three switches. Okay. Now, if you see all these switches, there was a possibility to create the loops, right? But what STP will does is that it will actually block one port in the whole topology and allow the other ports to be open for traffic. Let's see. Let's wait for some time and let's look at these ports when they will turn into green. Let me just remove this, and yeah, this has turned green, this has turned green, and but this has not turned green, which means that spanning tree protocol actually helped to avoid the loops. But how does this logic works? That's really important to understand how this logic works. So let me give you an understanding of the algorithm. First thing you need to understand is the concept of port designations, which means there are port designations. One is designated ports. In front of designated port, there will be a root port. And there in front of designated port, there will be a block port. So there can be either conditions. So what does it mean? Well, I'm saying that all these ports will have some designation. Either it will be designated ports, either they will be root port, or either they will be block port. So this will be a block port for sure that we can see. But how did spanning tree protocol identify that this should be the block port? So what we're going to do is we will run the algorithm, in the sense we will understand this algorithm in a simple way. So what it does, let's understand. Step 1. Now the step 1 here is that we select the root bridge. That is, we select a switch as a root bridge. How we do? Either we either by having a lowest priority or with the lowest MAC. Or with the lowest MAC. Now if you see here, let's see. Let's go into this switch and find out. Let's run show spanning tree and say, okay, this has a priority 32769 and it has a MAC address this one. So let's copy this. Put here, and let's also copy the MAC addresses. Okay, so this is the MAC address, this is the priority. So why is the priority 3276? Is because 32768 is by default the priority set in the switches. Then it adds 1 because all these ports FS01, FS02, which is these ports, they all fall in VLAN 1. So that's why this is 1. So VLAN 1 and that one is added to 32768 and it becomes 32769. Now let's see about this switch. Now if you see here, it also has the same priority but it has a different MAC. So let's copy. It is different MAC but it has the same priority. Let's look at this and the other switch. Now it also has a different MAC. Let's copy that one. But it has the same priority. If you see, it has the same priority. Yeah. So we just copy. Sorry. Now it also this is a tie in terms of priority. This is a tie. But what about the lowest MAC? Which one has the lowest MAC? Can you identify? It's 005, 004, or 0010. So if you see, the one which is 0004 has the lowest MAC value. So this will become the root bridge. Okay, pretty simple. This becomes the root bridge. Now, as I said, now we need to assign the designations to this port. Sorry for this. Let's say this one. Now let's assign the designation to this. Now please understand the root bridge, the ports which are connected to the root bridge are actually designated ports. So you can say these are designated ports. So I'm telling the algorithm how does the STP algorithm works. In front of these designated ports, you will have the root port. So this will turn into a root port automatically, and this will also turn into a root port automatically. Now you have assigned the designation of these ports. What is left is this port and this port. What is the designation of this port? I mean, in the picture you can see this will turn to block, but how it will, let's understand with the second step. Now in step 2, step 2 say that find the lowest path to the root bridge. What is the lowest path to the root bridge? Before I explain this, please understand one thing. According to IEEE standards, the fast Ethernet ports of 100 Mbps has a cost as 19. Okay, which means all these ports, all these connections, because they are all fast Ethernet ports of 100 Mbps. Let me show you. You see it? FS01, FS, these are all fast Ethernet ports of 100 Mbps. So the cost will, so the cost between them, the direct cost between them is 19. So which means that this is 19 the, of this link. This is 19, and this is the cost for this link, and this is the cost for this link. Now, but we're saying the lowest part to the root bridge. Now, if you look at this, if you start to see what is the what is the cost from here to here, this is 19 plus 19, this one and this one, so it comes out to be 38, right? Okay, that's good. Then we know that it is actually 38 from here. Now let's say we say, okay, fine, if this is 38, what about if we take in this part from here to here? Okay, this will also be again 19 plus 19, and this will be 38. Then even if you take a direct path from here to here, that is 19. If you take indirect paths, so these are actually, you can say these are indirect paths. These are indirect paths. So if these indirect paths to reach to the root bridge, they are also 38 and 38. Even so, direct paths, if the comparison is between the direct to direct, indirect paths to indirect paths. So the direct paths to the root bridge is 19. Okay, the direct path to the root bridge is 19. The indirect path is 38, and the indirect path from here to the root bridge is 38. So we said find the lowest path to the root bridge. Now if we say all the paths, even if it's a direct path, these ones, all the indirect paths, these ones, they are all of the same cost. So the comparison we are making is between direct to direct and indirect to indirect. There is no, we are not saying uh, we're comparing direct to indirect path. That's not the comparison we're doing. We're saying direct to direct path, from here to here 19, here to here 19. Indirect path, what is the value of indirect path? This is the indirect path, that's 38. This is the indirect path, that's 38. So indirect paths have the cost as 38. Direct paths have the cost of 19 towards the root bridge, which means this step, we have a tie in this step also. So the step 3 in the spanning tree protocol says, then find the lowest sender ID, bridge ID, or we can say a MAC, which is the lowest MAC. Now, now we know these are designated ports. We know these are root bridges. What is left is to find in these two ports. Now, if you find the lowest sender MAC, if you see it is 0005 and it is 0010, so which is the lowest one? This is the lowest one. The one which has have been the mark as the lowest one will turn into a designated port. So in front of the designated port is a block port, so that's why this will be a block port. And you can see clearly that this turned out to be a block port. So these are the steps to find out what are the designated ports, what are the root ports, and what is finally be a block port. How can you verify that these are designated ports and these are root ports and this is a block port? So if you go into the switch, you would find when you run show spanning tree, that's FS01 and FS02 are the designated ports. You see them, right? And they are forwarding traffic, and this is 19 is the cost. And if you see, this bridge is the root. So you can verify with the configuration. Now if you go here and try to run the same command, in this also it says this FS01 FS01 is a root port and FS02 is the block port. So this is FS02. You can actually verify this by going in and showing here. So this is FS02. FS02 is the block port and FS01 is the root port. Right, and then if you go here, The same thing, you find that it has FS02 as the designated port and FS01 is a root port. So here we can verify the configuration with our logic that we actually talked about. Thank you very much.